In our last lesson, we learned about significant figures. And my pattern was to always start with your first non-zero number. And a lot of mistakes I see people doing is they're not underlining it like I asked to, and then they miss. And as soon as I say just underline your first non-zero number, I don't see that many problems. So let's go through and underline our first non-zero numbers here. And you can write them down on a sheet of paper and practice with me. But there I have underlined all my first non-zero numbers. Okay? So here, my first non-zero number. Do we have a decimal? Yes. So everything to the right also counts. But there's nothing there, so I have 1 sig fig. Okay? Here's that same number. Okay? I have 100ths. And here I have 100ths. But I can see right now that this equipment that I measured this on is way more precise. Why? Because it measured down 2 more decimal places smaller, 2 more place values smaller. Okay, so that changes our significant digits or our significant figures. Here's my first non-zero number. Yes, I have a decimal. Everything to the right counts. I now have 3 significant figures. And here's my tenths, hundreds, thousands, 10,000s. So we measured, this equipment goes all the way down to your last estimated value being in the 10,000s place. That would be a much more expensive scale. Okay, over here, do I have a decimal? No, I underline my first non-zero number and my last, there's only 1. This last estimated value of this measurement was in the hundreds. Okay, not very precise. First non-zero number, a last non-zero number, because there's no decimal, right? And everything in between, I have 3 significant figures. And if you watch some other videos besides mine, they would be talking about sandwich zeros always count. This is a sandwich zero, it's in between. These trailing zeros don't count because I don't have a decimal. And that's where my pattern of underlining the first, if there's not a decimal, underlining the last comes in. It makes it a little simpler. Underline my first. Is there a decimal? Yes, there is, so everything to the right counts. 1, 2, 3, 4, 5 significant figures. 5 sig figs. Okay, so that's just a little review. And then what I want you to do is I want you to get out a piece of paper and practice with me. Okay, we're going to do a few of these. I have circled the ones that you should be doing and pause the video and then see what you get. Okay, and we'll see if we have the same number. We're going to do that set and then we're going to do this set. So just grab a piece of paper and see what you can do. Hit pause. Okay, our first one, I'm always going to start by underlining my first non-zero number and ask myself, is there a decimal? There is not. Everything to the right counts. That means I have 1, 2, 3, 4, 5 significant digits. Okay, underline the first, there's a decimal, that gives me 3. Underline the first, there's a decimal, everything to the right, that gives me 4. So remember, I'm going fast because you should have already paused this video and now you're double checking with me. Okay, I underline my first, there's a decimal, everything to the right counts. 1, 2, 3, 4. That's 4. Okay, I underline my first, there's not a decimal. I underline my last, that's 1, 2 significant figures only. And we have this little hat. I'm sure there's a technical name for it. I don't know what it is, so we're going to call it a hat. And what that means is I don't have a decimal here at all. But I did measure to the tens position. So my first non-zero number is there. My last non-zero number would be 2, but this line means it's all the way to there. So I have 1, 2, 3, 4, 5. Okay? Why? Well, because if I did put a decimal, that would mean that I measured all the way to the ones. But this equipment only measured with your estimated value to the tens. And so a decimal would not be the correct answer there. I would need that little hat on the tens place. Okay? So here's my first non-zero number. There is no decimal, but I do have that hat, so I have 1, 2, 3, 4 significant figures. Going down here, we have measurement. You can see that this equipment measured to the estimated value of the tenths. So first non-zero number, everything to the right counts. I have 4 significant figures. I have a decimal, first non-zero number, everything to the right counts with a decimal. I have 4. Here, first non-zero number, I do not have a decimal. Last non-zero number, that gives me 1 significant figure only. Not very precise there at all. Here I have my first non-zero number. I don't have a decimal, so I should do my last, but I see I do have this hat telling me I measured all the way down to there, so 1, 2, 3, 4 significant digits, okay? And now, hopefully after my explanation, you understand what they're asking for here. And we're talking about 3,000s with 1 significant figure. It has to be 3,000, so let's just start by writing 3,000 down, okay? And now I only need 1 significant figure. I'm going to underline that. And how do I make it only 1? Well, if I put a decimal there, it would be 4. If I don't put a decimal, I underline my last, and I have 1 significant digit there, okay? Let's do this one right here, 5 significant digits. So 3,000 is my number. If I put a decimal, there's 4, and now I can just add a 0. I have 5 significant digits, but notice the number is still 3,000. It just showed me that I measured 3,000 all the way down to the 10th position. 3,000 with 4 significant digits. Well, the first thing I do is I check, does a decimal give me 4? Yes, it does. I'm done. 3,000 with 2 significant digits. Well, my decimal gave me 4. And if I don't put a decimal, I only have 1. But I need 2 significant digits. I underline those 2. How would I show that? That's where that hat comes in to show me that I did measure to that number. So that makes it significant. Okay? Now, I'm not sure you guys saw that. Give yourself a chance. Pause the video. Do this. Okay, welcome back. We are going to use the value 7,000. So 7,000's my number. So I have to have 7,000 written down. So I can write it down all the way because it has to be 7,000. 1 significant figure. Well, I only have 1. There's no decimal. Underline the first, underline the last. I have 1. We're good. 4 significant digits. Well, I underline this. If I put a decimal, always check with your decimal. Now I have 4. I'm done. Okay? 6 significant figures on my 7,000. Well, when I put a decimal there, I have 4. And I can show that I went down to a more precise place value by adding 2 more. And now I have 1, 2, 3, 4, 5, 6. So hopefully this review was really good for you. And we are going to now talk about what happens with my significant figures when I use them in calculations. So there are 2 kinds of calculations we are only going to talk about. We're going to talk about multiplying and dividing. And we're going to talk about adding and subtracting. Okay? So multiplying and dividing, that's the lowest number of sig figs. What does that mean? This one's actually pretty simple, I think so. So 3 times 2 equals 6. Here, I'm going to write right above it, I have 1 significant figure here, and so my answer can contain answer equals the lowest number of significant figures. So my answer has to have 1 significant figure because they're both 1, so that's the lowest. Let's change this up. 3.00 times 2.0 equals, well, we know 3 times 2 equals 6. Let's put our significant figures above our numbers. 1, 2, 3 sig figs. Why? Because my first non-zero number and everything to the right counts. First non-zero number and everything to the right counts. This has 2 sig figs. Now I really beg you to circle your lowest number of sig figs. Why? Because people make mistakes. If that's circled, then you know I need 2 significant figures. So here's next. How do I make it 2? Well, I need a decimal and a 0, okay? And now I have 2 significant figures, okay? So, let's move on to another one. Let's do 2.01 times 4, okay? And if I put this in my calculator, this is going to give me 8.0. Okay, here I have 1, 2, 3 significant figures, and here I have 1 significant figure. This is my lowest number. My answer can only contain 1 significant figure, so I am going to underline my 1 significant figure. But I still need to see, does the one that's right next to it that we're not going to use, not this one, it doesn't matter, only the one touching it, will that round that? A 0 will not round. Remember, 0 to 4 stays the same. 5, 6, 7, 8, 9 rounds it up. This is going to stay the same, so this is going to be 8. Okay, and that's going to be my answer. I have 1 significant figure there. Now, let's try one where rounding will count, okay? So I'm going to do 2.02 times 4.0. Okay, now I have 3 significant figures here, and I have 2 significant figures here, and I'm going to circle how many I want in my answer. That's the lowest number, and my lowest number is 2 significant figures. Okay, so what does this equal? If I put this in my calculator, I have 8.08. I need 2 significant figures. I'm going to underline the 2 I'm going to keep, okay? And then the one right next to it and only the one next to it could round this up. Does an 8 round the 0 up? Yes, it does. So my answer is 8.1. And that's how multiplication works. I have a video for you to use, and we will go over some examples. So now, adding and subtracting, whole different rule. This is the least precise. Okay, what that means is the lowest place value. And I find it very easy for people to line it up and decide, okay? So we have 8.01 plus 2, okay? My lowest place value is the ones. My answer is going to be in the ones. But notice, when I line this up, I have 10.01. There's nothing here. I just make a line to where my lowest place value is here, okay? So my answer will be 10. So we are in the place of the ones. That's where my lowest place value was. See, this is more precise. We can't add more precise numbers to a lower precise measurement, okay? Because, remember, my 2, since that's my estimate value, could be 2.99. Okay, we don't know what that number is, so we can't use that over here in our calculations. Let's do one more. Let's say I have 0.020 and I have 0.31102. Okay, so I'm going to first add it all up, 0.33102. Then I'm going to cut off everything that's not as precise as the other one, and I'm going to make sure that number round. It does not, so I have 0.331 is my answer, because my precision goes all the way down to, let's do our place values again, tenths, hundredths, thousandths. So my number needs to be in the thousandths. This is in the 10,000ths, but this one wasn't measured to the 10,000, so I can't use these guys except for to see if they might round. You have some examples in my notes that go through how to do this step by step. I also have 2 videos for you to look at, and I am going to do 2 problems with you on the worksheet right now. Here's your worksheet, and the first thing you'll notice is you have addition and subtraction problems here, and then down here we have multiplication problems. Those are 2 different rules. So this one is to the place or to the precision, and it is really nice to write this. I already have it typed for you. Write the rules. Multiplication is the lowest number of sig figs right there. Okay. So we're going to start, and I'm going to show you 2 different ways to handle this. We're going to put all this in our calculator, and our unrounded answer is 22.313 centimeters. Don't forget your units. When we add centimeters together, it stays centimeters. Now, we can line them up just like I showed you before, okay, but you don't need, okay, and we ended up with 22.3, and then 13 is over on the more precise, or the precision that we can't use anymore because we have to use the least precise. The 1 doesn't round it, so we have 22.3. We can also look at it like this. 4.732 goes to the thousandths, 16.8 goes to the tenths, and this one goes to the thousandths, or 3 positions past the decimal, 1 position past the decimal, 3 positions. The least precise is 1 decimal place. Okay, and so we only need to the tenths, or 1 position past the decimal. That's all we need there. Does the 1 round it? No, it doesn't, and there's my answer, 22.3 centimeters. When we go to multiplication, we have our unrounded answer is 82.852. Now, how do I know how many sig figs there? Well, this is multiplication. It's the lowest number of sig figs. So 37.6. This has 4 sig figs. The lowest one, we're going to circle it so we don't forget. I need 2 sig figs. 1, 2. Does that 8 round my 2? Yes, it does. So I have 83, and my units are kilowatts times hours. So 83 kilowatt hours. You can put a little dot there to remind you that was multiplication. Okay, so try the rest. We'll go over them in class tomorrow.